Hello and welcome. In this video, we're going to be solving the Mechanics 1 Cambridge 9709 May-June 2025 paper. It's crucial revision for you going and wanting to attempt this paper. It's going to be very helpful. We're going to start by solving the first question straight away. First question says, a block of mass 12 kilograms is being pulled up by a rope up a rough plane. What does the word rough tell you? It tells you that there will be some friction. The plane is inclined at an angle of 20 above the horizontal. The rope pulling the block is parallel to a line of greatest slope of the plane. The coefficient of friction, which is mu, is given as 0.4. Acceleration of the block is also given. Find the tension in the rope. My advice to you is always draw these kind of questions and draw your free body diagrams. So we know that the angle is 20 degrees with the horizontal. This is our block, and let's draw the free body diagram representing all the forces acting on this block. So we'll have the weight straight down. It's going to be the mass, which is 12 kilograms, times the acceleration of gravity. For Cambridge, you take it as 10, so G equals 10 meters per second squared. Now, what other forces are acting? We have a tension that's pulling the block up, so tension is this way, and then we have the normal force, which let's call it force R, and we also have friction. If the block is moving up, it's accelerating or moving up the plane, then the friction is going to act in the opposite direction, and since the block is already moving, it's going to have a special the friction force is going to equal a special equation, which is called mu times R, which is the normal over here. So this is my free body diagram. By the way, whenever the block is moving, we know that the friction is maximum friction, and it has this equation, F max equals mu times the normal force. And sometimes if it's not moving, but it tells you on the point of moving or about to move, this also indicates that friction is maximum, and you can use mu R for your friction, and this would come in 90% of the questions. Okay, now first of all, looking at this, I will not take my x and y, the horizontal and vertical plane, as my, I won't take this plane as my plane of resolving. I don't want all the forces to be in this plane, because think about it, I need to resolve the tension, I will need to resolve R, and I will need to resolve the friction in both x and y. It's going to be a hassle. So a smarter thing to do is to take your x and y as these two directions. What are these two directions? These directions are basically the direction of the slope and perpendicular to the slope. So this plane over here is going to be your x and y. So what I mean by that, I mean that I want to resolve all the forces in these two directions, except the forces that are already in one of those two directions. So tension here is already up the slope, so it's fully in my x-axis, so no resolving needed. R is fully in the y-axis. Friction is fully in the x-axis, just in the negative, it doesn't matter. The only force that's causing me trouble here is weight. That's the only force I'm going to resolve. And I'm going to take this deal, other than resolving three forces using the normal, horizontal, and vertical plane, I'm just going to resolve one force using the parallel to the slope and perpendicular to the slope axis. Okay, so I'm going to resolve into a y component and a x component. So if this is 20 degrees, this would also be 20 degrees very easily, because if you look at this green triangle, this is 90, right? If this is 90, that means that this is 20 plus 90, that's 110. 180 minus that, then this is 70 degrees. If this is 70 degrees, and I know that this is my x-axis and this is my y-axis, they must be perpendicular. So if this is 70, this whole thing is 90. This is 70, then this one must be 20. So I just explained to you why this is 20 over here. So if this is 20, I'm going to start from my force going into my angle. It means cosine. So this is going to be 12g cosine 20. And the other component, I'm going to start from my force, go away from my angle to get the other components, so it's 12g sine 20, and I know that my acceleration is up. Now I'm ready to use my Newton's second law. Here there is an acceleration, so sigma f, I'm going to do the sigma f in y first, in the y direction. This is y, this is the x. Usually it's best to always start with the y direction, and I will tell you why. Sigma fy, you need to think about it. Is there any acceleration in the y direction? No, the acceleration is just up the slope. The block is not flying this way or protruding through the plane, right? So there is no acceleration in this direction. So sigma f in the y is equal to m times a, which is 0. So sigma f in the y is equal to 0. That means that forces are balanced. There is no net force. That means that forces in this direction in the positive y will equal forces in that direction. Okay? So the forces R is going to equal the force 12g cosine 20. And now I already did the first part of my equations. I did sigma fy. And I always start from y because you will always get an expression for the normal, which then you are going to use over here as I will show you. Let's now do sigma f of x. Sigma f of x is going to equal mass times acceleration because we do have an acceleration over here. So sigma f of x equal mass times acceleration. I need to take always in dynamics, take the direction of the acceleration as positive. So I'm going to take up the slope direction as positive, not because it's up, just because the acceleration is pointing that way. If the acceleration was down, I would have came here and told you, hey, let's take down as the positive direction. Always do that. There is no negotiation in this one. So any force that's pointing upwards is going to be positive. So this tension is up, so it's going to be plus tension. Any force down is going to be minus. So minus friction, which is mu. Mu was what? Mu was 0.4. So minus 0.4. Multiply R. What is R? R I already got as 12g cosine 20 from my first equation. So let me just plug in 12g cosine 20. What else other than friction is going down? I have a 12g sine 20 is going down, so it's going to be minus 12g sine 20. Do I have any other force in the x-axis? No, just these three forces. So so this left part is the sigma forces, and I'm going to equate it to the right part, which is mass times acceleration. What is the mass? It's 12. Acceleration is 2. So 12 times 2 is basically just 24. And from here, I can solve for tension. So tension is going to equal 24 plus this term, which is 0.4 times 12g cosine 20. And then when I move this to the other side, it's also going to be plus, so plus 12g sine 20. If you plug that in the calculator, you should get a value for tension of, making sure G is 10 and making sure your calculator is in degrees, sine 20. So it would give me tension value of 110 newtons to 3 significant figures, and this is the correct answer. Okay, let's move on to the next question. So this question says we have 3 coplanar forces. Coplanar means they all act on the same 2D plane. There is nothing into the page more, or like there is no 3D space here, okay? Magnitude P, 5 and 10, and they all act at a point O, shown in the diagram. The resultant of these 3 forces has magnitude Qn. So the magnitude of the resultant, the net force, has a magnitude of Q newtons, and acts in a direction perpendicular to the force of Pn. Okay, that is very interesting. Pn is vertical, so definitely if Qn acts in a direction perpendicular to that, so Qn is going to be fully in the x-axis or fully horizontal, right? So Qn is going to be fully in the x-axis, either positive or negative. I don't care. I just know that it's going to be fully in the x-axis. So that means that it's not going to have any y component, right? And Q, this is the net force. This is after adding everything, right? So over here, what I'm going to do is I'm going to use that. I'm going to show you how. First, let's start by resolving the forces. Do I need to resolve P? No, because P is already in the y-axis. Now I'm taking x and y, horizontal and vertical, as my axes, because that makes sense in this example. Over here, this 5, I'm going to resolve it into 5 cosine 60 and 5 sine 60. Why this is cosine? Because I start from my force moving into my angle, closing on my angle is cosine, away from my angle is sine. Similar to this 10 degrees, when I move into my angle, is going to be, you guessed it, cosine. This 10 cosine 30, and this over here is going to be 10 sine 30. Now, the net force is basically, has two components, a component in x and a component in y, correct? However, here it told you that Qn acts in a direction perpendicular to the y-axis, so the y component is 0. So basically, adding the components in the y direction should yield a 0 answer. So that means that 5 sine 60 plus Pn should equal 10 sine 30, right? If I do 5 sine 60 plus P minus 10 sine 30, and I know that at the end the y component is 0, that means that when I move this to the other side, it's just going to become equal, like this. And from here, I can find the value of P, which is going to be 10 times sine 30 is 10 times half, which is 5, minus 5 sine 60, that will give me 0.67 newtons for P over here. And to find the value of Q, I can now get the sigma forces in the x direction, which is going to be 5 cosine 60 minus 10 cosine 30, 10 cosine 30, and that is going to give me the component in the x direction. So 5 cosine 60 minus 10 cosine 30, that is equal to minus 6.16 newtons. So that tells me that the x component of Q, the net component of all these forces in the x direction, is going to be 6.16 newtons to the left, and the y component of Q is 0. So basically this is going to be my Q. Okay, so this is going to be my Q over here. This is the answer to this question. Okay, let's read this question and try to solve it together. Okay, this question says the diagram shows the velocity time graph. Straight away, when you have a velocity time graph, you need to know that the slope or the gradient of this graph is basically y over x, v over t. V over t is acceleration, so the slope is acceleration, and the area under the graph v times t is basically displacement. So the area under graph is equal to displacement. I'm gonna call it s. This is what should come to your mind straight away when you hear the word velocity time graph. So the velocity time graph of the motion of a cyclist, the graph consists of 3 straight line segments. The cyclist passes a point O with speed 3 and then accelerates for 10 seconds with constant acceleration. I already know this is a constant acceleration because the slope here is constant and slope is basically acceleration, so that means that acceleration is also constant. So it already gave me the acceleration, 0.5. He then travels at a constant speed for 30 seconds before decelerating, coming to rest at point P, covering a distance of 80 meters while decelerating. So the deceleration started from here. Deceleration is decreasing in speed. So this part of the graph is clearly the deceleration part, and the area under this part, the area is basically equal to the displacement or the distance over here. So this area should equal 80 meters. Now the question tells me find the total time taken for the journey from O all the way to P. So what I'm gonna do is, first of all, let's think about this. I have the times until 40, right? So I just need to know how much time did it take for this guy to go from here all the way up to a speed of 0, right? So what I can do is I can, let me see what I know about these 2 points. So this is point number 1, this is point number 2. The initial velocity at point number 1 is just a speed u, I don't know it. I don't know the deceleration value as well. I don't know how much is it. All I know is just this has a distance of 80 meters, and this is not enough for me to solve. So let me start by getting some information. So let's say, oh, I know also another piece of information, that at the end, the final velocity is 0. So let's write them down. Final velocity is 0. U is, I don't know. Acceleration also, I don't know. And I know S is 80 meters. If I got U, right, this is enough for me to solve, because whenever I know 3 things in kinematics, I can use the Saviot equations. So let me try and see how can I find U. U is basically the final speed of this segment over here, right? Over here, I know the initial speed, I know the time, and I know the acceleration, which is 0.5. So I can use that to find V. So let's hold on for this for a second, and let's write the things that we know for this first part. So the initial velocity of this segment, please note that this things that I wrote is for this segment. The things that I'm going to write now is for this segment. Okay, you need to differentiate. So U is 3 meters per second. Acceleration is 0.5 meter per second squared. Time is 10 seconds, and I want the final velocity. So the letter that I didn't mention looks like it's displacement. So I'm going to use the Saviot equation without displacement, which goes like this. V equals U plus AT. So V equals 3 plus 0.5 times 10. So 3 plus 5 is basically 8 meters per second. So this over here is 8 meters per second. Now I can use that to get this time period over here. Right, so let's erase this. Now I can use that to, now I know that my U is 8 meters per second. Right? Now I can use V, U, and S to find A. I didn't mention T, so I'm going to use the equation without a T, which goes like this. So 0 squared equals 8 squared plus 2 into acceleration into displacement, which is 80 meters. Okay, so from here I can find acceleration. So acceleration is going to be negative 8 squared, so 64 over 2 times 80, and I would expect acceleration to be in the negative direction because my velocity here is positive and I'm decreasing, right? My velocity is decreasing, so it makes sense that my acceleration is a negative value. So negative 64 over 2 times 80 is basically negative 0.4 meter per second. Actually, I didn't need to get the acceleration, I just wanted time. So actually I should have used the equation without acceleration to find time, which goes like this. S equals U plus V over 2 times time. So S is 80, U is 8, V is 0 over 2 times time. From here I can find the time. So 160 equals 8t. So time is going to be 160 divided 8, which is 20 seconds. So the time is 20 seconds. So this period is 20 seconds from here to here. That means that on the graph, this part over here should be 60. So this over here is 60 seconds, right? So let me erase all of this. So the total time taking from O until P is basically going to be 60 seconds. So this is, so my answer for part A is 60 seconds. Okay, let's take a look at part B. I think it should be over here, yes. So on the given axis, sketch the displacement time graph for the cyclist's journey from O to P, showing on your graph the distances traveled after 10 seconds and 40 seconds. Okay, this is an interesting question. Let me copy all of this and bring it over here so we can visualize what is happening. Okay, so over here, I need to sketch a displacement time graph, okay? All I know is this velocity time graph. So first of all, starting from displacement time graph, what is this gradient of displacement time graph? Gradient of displacement graph is y over x, so s over t. Displacement over time is velocity, so the gradient is velocity. So my gradient will represent my velocity over here. I need to take care. So in this first section, I need to know how much displacement did I move, right? How much did I move, right? So I can do that by finding the area under the graph, the area of this trapezium, right? So the area is going to be this plus this over 2 times this. So it's going to be 3 plus 8 over 2 times 10. So that is going to be 3 plus 8 divided 2 times 10 is basically 55 meters. 55 meters. So I basically moved 55 meters. Let's say this is 55 meters in 10 seconds. So I have this point and I was starting from 0 and 0. I started from 0 displacement at 0 time. However, I need to know how did I move there? Did I move there with a constant velocity? Do you think the velocity was constant? Yeah, if the velocity was constant and the gradient here is velocity, then I would just connect them like this. I would say, okay, I'm done, right? Velocity is constant and I had a constant line, constant gradient line. However, here the velocity is not constant. The velocity is increasing. It was 3, it was 4, 5, 6, and went to 8. So the velocity is increasing. That means that in this segment, the gradient should increase, right? So in this segment, the gradient should increase, correct? So I should draw it with an increasing gradient. Do you think this is an increasing gradient or this is an increasing gradient? What do you think? Yeah? This is an increasing gradient, right? Because the gradient is the slope. The gradient here was 0. The gradient is getting steeper, steeper, steeper as we go. So this is an increasing gradient. Let me draw this a little bit down. 55. So over here, that's my point. And I'm going to draw it in a, not a straight line. I'm going to draw it in a curved way. Like this, okay? Now, after this period from 10 to 40, what happened? From 10 to 40, I was moving with a constant speed, right? I was moving with a constant velocity. So that means that the rest of this graph is going to have a constant gradient, right? So it's going to be something like this because the velocity here is constant. So I need my gradient in this period to be also constant, correct? Type. I need to know how much did I move in this period, right? So again, I'm going to get the area under the graph of this period. So the area is going to be this part, which is 30. 40 minus 10 is 30 times 8. So 30 times 8 is basically 240. So this part is 240. So 240 in order to write it here. So this part from here to here, I move 240. So on the graph, I need to add 55 to 240. So this is going to be 295. So this is 295 over here, right? Then what happened after? Over here, I have a deceleration, okay? However, the velocity is positive. I'm moving with a velocity of 8, so I'm moving forward. Here, I'm moving forward, but at a little bit lower speed, like 7, and then 5, and then 6, and then I reached to a point where the velocity was 0, right? So the velocity over here is decreasing, right? The velocity over here is decreasing, so I will need to draw do you think I should draw a constant gradient, an increasing gradient, or a decreasing gradient? I'll follow my velocity. I'll draw a decreasing gradient. So I need to draw something that looks like this. Decreasing gradient until the velocity reaches 0. So I will decrease my gradient until it reaches 0. So I'm going to draw something like this, right? And over here, this is a flat line indicating that the gradient is 0, which means that the velocity is 0, which means that this part over here is 0. This is 60 seconds because this point is this point. However, I need to know how much did I move in this part. I already know it is 80 meters, so I'll just add over here 80 meters. So 295 plus 80 is going to equal 375, and this is going to be my answer over here. Please, you always have to make sure of how much do you understand the graphs. And by the way, I have a very, very huge gift for you guys. I've done my mechanics, year one mechanics, both at Edexcel and Cambridge, full tuition alternative course. This course is amazing. Let me show you a preview. This course is basically just me solving, if you go and look at the right, literally every single section of mechanics that you will need, explained thoroughly every single topic, and solving examples. And please note that I always focus on solving. You will find the solving questions the longest, okay? In every single chapter, you will find the past paper questions, the solving, the worked examples are always the longest videos, okay? Because I'm focusing on literally showing you how to solve. This is designed to be an alternative to tuition course. This course is absolutely amazing. I'm gonna leave a link to it on the description. You can find my email, abdurrahman.alminyawi@outlook.com. Email me titled Mechanics Udemy course, and I'll send you a discount code. However, this is very, very worth it to invest in your studies, as this is literal gift that I would have given myself when I was at your age. Please go check it and let me know, send me emails, and always comment in the comments down section. It's always helpful to read all of your comments. Okay, let's continue to solve question 4. This question says that we have a lorry of mass 18,000 kilograms traveling along a straight road. It says on a horizontal section of the road, the power of the lorry's engine is constant. Power is constant. There is a constant resistance of motion, 1,600. The steady speed which the lorry can maintain with the engine working at power, the same power, is 30. Find the value of P. We want to find the value of the power. First of all, you need to think about what do we mean by steady speed. Steady speed indicates that we don't have any acceleration, right? So from sigma F equals ma, if acceleration is 0, sigma F is 0. That means that the forces are balanced. This is your starting point. Always think about this. So if this is the car, there is a resistance of motion of 1,600 newtons. So if the car is going this way, this is the velocity, then the resistance is the other way. Can you tell me how much should be the driving force? It should be also 1,600 newtons. Why? Because we're at steady speed. The forces are balanced. Acceleration is 0. So this is a major hint that told me that my driving force from my engine is 1,600 newtons. Okay, and I have the formula that tells me that power is the force, the power from the engine is going to be the force of the engine, which is the driving force, times the speed, right? So power is going to equal the driving force, which is 1,600, times the speed, which is 30. So 1,600 times 30 is going to give me an answer of 48,000 watts. This is going to be my answer over here. At an instant when the speed of the lorry is 16 meters per second, its engine is working at this power. Find the acceleration of the lorry at this instant. Okay, so now we're accelerating. We're no longer moving with a constant speed. So what I can do from here, I know that power equals driving force times the velocity. So from here, I can find my driving force, because FD is going to equal power over velocity, right? So it's going to equal 40,000 watts over the velocity, which is 16. So 40,000 divide 16, that's going to give me a force of 2,500 newtons. And I know that this is going to be the driving force. So again, if I draw my diagram, that's my driving force. Right now, my resistance to motion is 1,600 as it is. So now I have an acceleration because the forces are unbalanced. So sigma force is going to be 2,500 minus 1,600, which is going to equal to mass times acceleration. My mass is 18,000. Acceleration is A. So from here, I can find A by dividing both sides by 18,000. So if I plug in the calculator, 2,500 minus 1,600 over 18,000, that's going to give me an acceleration of 0.05 meter per second squared. This is going to be my answer over here. Okay. When the lorry has reached a speed of 20, it begins to ascend a section of a road inclined at an angle alpha. So there is an inclined section at what angle? At an angle alpha, and the lorry is ascending it. Okay. So let's actually draw it right here so we make it a little bit easier to draw. The engine now works at this power. There is no change in the lorry speed as it ascends the hill. So again, forces up the hill should be balanced. The constant resistance to motion remains 1600 newtons. We need to find the value of alpha over here. So there are a couple of ways we can solve this using the drawing a free body diagram and getting the equation of motion using Newton's second law, or we can use the work energy principle. And I'm going to show you the work energy principle later, but now this, and you can come again and solve this question using the work energy transfer after I explain it to you and see if you can get the same answer. So over here, weight is going to be 18,000 G. I'm going to have reaction force. I'm going to have the force of the engine. Let's call it FD. I'm going to have 1600 newtons resistance to my motion. And now I just need to resolve my forces. This is going to be 18,000 G cosine alpha because this is alpha. This is going to be 18,000 G sine alpha, right? Now, y direction is not going to really help me because I don't really need r in anything. I just know that r is equal to this. That's it. I know that there is no acceleration also up the slope, so the forces up the slope are also balanced. So the driving force should equal the 1600 resistance plus 18,000 G sine alpha. Now, I know that the driving force I can get using force is going to be power over velocity. So the force is going to be the power given, which is 120,000, over the velocity given, which is 20, right? So this is basically going to be 120, 6,000. So the force is 6,000 newtons. Right? So 6,000 newtons. So I'm going to replace this 6,000 over here. And now I have an equation that I can use to find alpha. So what I'm going to do is I'm going to subtract 1,600 from both sides. So 6,000 minus 1,600 is going to be 4,400 equals 18,000 G sine alpha. This is 18,000. Okay, now I'm just going to divide both sides by 18,000 G, divide 18,000 G, and this is going to cancel. So to get alpha, I'm basically going to get sine inverse of this. So if I just plug in my calculator, sine inverse of 4,400 over 18,000 times 10, and I will get the alpha as 1.4 degrees. And this is the correct answer. Now, let's solve the next question. So, question 5 says, there's a particle P of mass m kilograms and has a speed of u. Its momentum is 4 Newton seconds and its kinetic energy is 16 joules. Find the value of m and the value of u. Now first, what do we know about momentum? We know that momentum equals mass times velocity. And what do we know about kinetic energy? Kinetic energy is half mass times v squared. So its momentum, which is 4, is equal to mass times velocity, and its kinetic energy, which is 16, is equal to half times mass times velocity squared. So from here, what we can do is we can solve this simultaneously. How we can do that? We can, let's say we were gonna make mass subject over here. So 4 over V is equal to mass, and then we're gonna substitute it over here. So 16 equals 1 over 2 into 4 over V multiply V squared. So this V cancels with one of the V on top. Half times 4 is basically 2, so 16 equals 2V. So the velocity is equal to 8 meters per second. That is going to be the speed U. And to get the mass is easily 4 over the speed or the velocity that we just got. So it's equal to 0.5 kilograms. Okay. Now, it says that P is now projected on a smooth horizontal surface with a speed V directly towards a particle Q of mass 1.25 kilograms, which is stationary. So P is here. This is particle P. It's projected on a smooth surface with a speed V and is directly towards a particle, let's name it Q, and it has a speed of 0 meters per second. Particle is 1.25 kilograms and particle P is 0.5 kilograms from the first question. Now it says after P and Q collide, the velocity of P is W. So this is the after velocity, here is W. And the velocity of Q is going to be 2W. The loss of kinetic energy in the collision is 25. The question wants the value of V and W. So let's start by what we know about the conservation of momentum equation. So it says that m1 u1 plus m2 u2, where u1 is the speed of object 1, which is P initially before the collision. U2 is the speed of object 2, which is Q initially before the collision. This should equal m1 v1, which is the speed of P after the collision, plus m2 v2. So let's write that. So what's the m1? m1 is the mass of P, which is 0.5. u1 is basically the velocity before the collision of P, which is v, plus m2, which is 1.25, the mass of Q, times u2, which is 0. This should equal m1, which is 0.5, times the velocity final of P, which is W, plus 1.25, which is the final speed, times V2, which is the final speed of Q, which is 2W. So we can simplify this a little bit. 0.5 V, this part is 0, equals 0.5. 1.25 times 2 is basically 2.5 W. 2.5 W plus 0.5 W is basically equals to 3 W. Now we have two unknowns, so if we have another equation we can solve, and this equation we can get using the fact that we know what is the loss of kinetic energy type. Loss of kinetic energy means that the kinetic energy final minus the kinetic energy initial is equal to 25. No, sorry, the kinetic energy initially is 25 joules more than the kinetic energy finally. So we started with a kinetic energy, and then we ended with a kinetic energy as well, but 25 lower than the original one, because we lost 25. 25 was lost as heat, friction, or whatever. So the initial kinetic energy was what was just the kinetic energy of P, because Q had a speed of 0, so no kinetic energy. So the initial kinetic energy is half times P times the initial speed of V, which is V squared, minus the final kinetic energy, which is the kinetic energy of both particles. So for P is going to be half times the mass of P times the speed of P after the collision, which is W squared. And then we add to that the kinetic energy of Q after the collision, which is half times 1.25 times the speed of Q squared, which is 2W squared. Now, let's get an expression for a V. From here, I can divide both sides by half to get V equals 6W, and let's substitute it over here. So this is going to be half times 0.5 is basically 0.25. Instead of V, I'm going to put in 6W, and this is going to be squared, minus half times 0.5 is 0.25, W squared plus half times 1.25 is 0.625 times 4W squared. 4W squared. Okay. Then let's do this. So 6 squared is going to be 36. 36 times 0.25 is 9. So over here I have 9W minus this is 0.625. So 0.625 times 4 is basically 2.5W squared. This 2.5 plus this 0.25 is going to equal 2.75W squared. So this is basically 2.7, this is squared. 2.75W squared. And this is all equal to 25 because the subtraction that we did, the initial kinetic minus the final kinetic, should equal 25. So from here I can find W. So 9 minus 2.7 is basically 6.3W squared. So this is 6.3W squared. I'm going to divide both sides by 6.3. So this cancels. I'm going to take square root of both sides. So W is square root of 25 over 6.3, which is going to give me an answer of 1.99, which is basically 2 meters per second. That is W. The question wants also V. Very, very easily, V is just 6 times W, so V is 12 meters per second. Okay. Now, let's move on to question number 6. Yeah. Okay. This question is interesting. So let's try and attempt it together. This question says that we have two particles, P and Q, masses 0.3 and 0.6 kilograms respectively, are attached to the ends of a light. Light is basically a form or a way to tell you that tensions throughout the whole string is equal. So the tension on this part is going to equal the tension on that part. Inextensible tells me that the displacements that the particles move, the accelerations that the two particles are moving, the velocities of the two particles at the same instant are basically equal. So throughout the string, accelerations, velocity, and displacements are equal on both sides. The string passes over a smooth pulley fixed at point P, where the inclined planes AB and BC meet. P lies on a smooth plane, so no friction on this plane, which is inclined at an angle theta to the horizontal, where sine theta is 0.4. Q lies on a plane BC, which is inclined at 30 degrees to the horizontal. String is taut, and the particle can move on the lines of greatest slopes. The particles are released from rest. Given that BC is smooth, so also BC has no friction. Find the tension in the string and the acceleration. So, over here, you always have to start the same starting, which is basically just drawing a free body diagram of what is happening. So let's do that. Let's draw for P first. What are the forces acting on P? We have the weight, which is 0.3 G. We have the normal force, although we're not going to really need it over here. Let's call it R. P. We have the tension. However, now you need to think which particle is going to move down. P, which is 0.3 kilograms, or Q, which is 0.6 kilograms. Q is heavier, okay, and also it's on a steeper angle, because if you actually want to get theta, you do shift sine 0.4. That's going to be 23. So this angle is definitely 23. So this particle is heavier and on a higher slope. So definitely this particle is going to move down and this particle is going to move up. So if P is moving up, that's going to be the tension on P. Do we have any other forces? No. Now let's resolve. We're going to have this as 0.3 G cosine theta, and we're going to have this component of the weight as 0.3 G sine theta. That's the only force I'm going to resolve, because my x and y are basically, the x direction is the parallel to the slope direction. Let's draw it actually parallel to the slope like this, and the y is the direction perpendicular to it. Okay. Now I'm done with P. Let's move on to Q. So let's draw it again. We'll have 0.6 G as the weight. Tension is also over this side. and we're gonna have the normal reaction RQ. Do we have any friction? No, so we just straight away resolve the weight into two components, one in the y, 0.6 g cosine 30, because this angle is 30, we're closing on our angle, and one down the slope, which is 0.6 g sine 60. Sorry, sine 30. This angle is 30. Okay. Now we can start doing the equations of motions. Here, no absolute use of doing sigma f in the y direction for both, because we don't have any friction. All you're gonna get from the y direction is that, okay, forces are balanced in the y, reaction is equal to 0.3 g cosine theta. That's about it. You're not gonna use it. In part B, however, we're gonna use it, and I'll show you how in a second. So right now, let's do sigma f of x for particle p, taking which direction as positive. Should I take up the slope or down the slope? If you said up the slope because that's the direction of acceleration of p, I'll tell you you are absolutely correct. Now, forces up the slope are tension minus 0.3 g sine theta. What is sine theta? Sine theta was given to me as 0.4, so I'm just going to write it as 0.4 straight away. And this is going to equal 0.3, the mass times the acceleration. Now, let's do the same, sigma fx for particle q, taking now down the slope as positive because that's the direction of the acceleration. So the force down the slope is basically 0.6 g sine 30. Sine 30. And then up the slope is the tension, so it's going to be negative. This is going to equal to mass times acceleration. Again, what I can do here is actually, let me rewrite this in the other way around so it's easier. So I'm just going to write it as minus t plus 0.6 g sine 30. So minus t plus 0.6 g sine 30. I just removed them around. It's literally nothing. Why did I do that? Because I want to solve these simultaneously, and I noticed that this is a positive t, this is a negative t. So if I added both equations, this t and this t will cancel, and I'm going to have a negative 0.3 times 10 times 0.4 plus 0.6 times 10 times sine 30. That is going to give me an answer of basically 1.8. That's going to equal 0.3 plus 0.6, which is 0.9a, giving a as 1.8 over 0.9. So a is going to be 2 meters per second squared. And to find tension, the question wants the tension and the acceleration. To find tension, I'm gonna substitute this acceleration in this equation. Let's say, feel free to choose any. I'm gonna choose the first one. So t minus 0.3, actually 0.3 times 10 is just 3 times 0.4 equals 0.3 times 2. So tension is going to equal 0.3 times 2. I'm going to move this to the other side so it becomes plus 3 times 0.4. That is going to give me an answer of 1.8 Newton, and that is the correct answer. Okay, now let's look at part B, which is the interesting part over, I think it's this one. Let's actually get it over here so we can see the drawing as well. Okay, now it says that it's given that the plane BC, I'm reading here now, that the plane BC is now rough. So now we have tension, friction in this part. And it says that the work done against the frictional forces when Q moves 2 meters down the plane is 1.8. You should assume that P does not reach the pulley and Q does not reach C. Use an energy method to find the speed of Q when it has moved 2 meters down the plane. What do you mean by energy method? We need to use the work energy principle, remember? And I talked about this thoroughly in my course. This work energy principle is the best way to solve any kind of question. It solves every question with every scenario. When you master it, you can solve any work energy related question super easily. It goes like this. It says that work in minus work out of the system is going to equal the change in kinetic energy of the system plus the change in gravitational potential energy of the system. Okay, so first of all, part B, nothing is gonna change. Nothing is gonna change regarding the free body diagram. Okay, if I'm gonna redraw it, I'm gonna redraw the same thing. However, in part Q, we are going to have another factor, which is going to be the friction. We are moving down. However, I never recommend this. I always recommend you to redraw everything so you don't miss anything. However, what I'm gonna do here is I'm just going to add. Now we have BC is now rough, correct? So we drew the weight, 0.6 G, we drew the normal, we drew the tension. Tension is now different. You cannot take the same tension from before. When anything changes, everything changes. Acceleration is also different. So we drew our weight, our tension, our normal. We resolved the weights. There is one more force, that is the friction force. Q is moving down, so the friction force is going to be maximum and is going to be up. So we're going to have a friction force upwards over here. That's the only difference. Now, to apply the work energy system equation, I told you, when I was explaining, I told you that it's work into the system minus work out of the system plus change of kinetic energy of the system plus change in potential energy, gravitational potential energy of the system. But what do I mean by the system? What's the system? Here you are free to choose whatever you want. If you want to choose P alone, you will apply this equation to P alone and then Q alone, and then you will solve. If you are going to apply it for P alone, you need to think about the work in part. The work in part is going to be the forces that pull or add energy to P. What force here adds energy to P? But by the way, we never consider the weight forces or weight components in work in or work out. Why? Because I already accounted for the weight forces in the delta GPE. So work in is any external force other than the weight that gives energy to my system. So if I'm taking P only as my system, I'll have the tension. So the work in is going to be tension minus work out. Is there any work out on P? Is there any work out? No, and this tension times the distance. Work is force times distance. So tension times the distance is moved, which is 2, minus work out on P is 0. There is nothing. I don't have any external force. I don't have any friction. I don't have any resistance to P, right? So that's going to equal the change in kinetic energy of P plus the change in potential energy of P. Also, similarly, you need to take the system as Q now. So what you're going to do is for Q, if Q is your system, you're going to take work in for Q. What forces are giving work in for Q? What forces other than the weight? Nothing. Nothing is pulling P. Actually, everything is acting against it. So work in for P is going to be 0. Minus work out for P is going to be the work done due to friction, which is 1.8 joules given from the question, and also plus the work done due to this tension force, because this tension force is now a resistive force. It's resisting my motion. Q is trying to move down, and tension is trying to pull it. So it's going to be tension multiply 2. Right? So now you did the same for Q. You're going to solve, eliminate tensions, and get the speed, whatever. This is one way. However, the better way is to consider the whole system. So both particles at the same time. So work in is basically any force that is on both particles that is causing energy into the system. When you consider the system as a whole, the tension cancels. You don't consider cancel. The tension dissolves in the middle. You just consider the external parts. Okay, so whenever you take the system as a whole, you cancel the tensions in one part. That's why I like it. It's just one straightforward way. So work in for this system, when you think about it, work in for this system is what? Do I have any external force that's causing energy into my system? You tell me weight. I tell you no, we do not include the weight forces in work in. We include it in the delta GPE. So work in seems like it's 0. Then minus, what is work out due to the system? Work out due to the system, excluding the tensions as well, is just the work done due to friction, which is 1.8, very simply. That is going to equal the change in kinetic energy. However, you need to take care that you're taking both particles, so you need the change in kinetic energy of both particles. So let's start by P first. So it's going to be half times the mass of P, which is 0.3, times the change in speeds squared of P. So it's going to be V squared of P, which is the final speed of P, minus the initial speed of P, which was 0 squared. That is the change in kinetic energy for P, because the system starts from rest. Okay, and then we need to add to that the change in kinetic energy of Q, which is half times the mass of Q, which is 0.6, times the final speed of Q, which is going to be the same speed as P because it's an inextensible string, minus the initial speed of Q. It also started from rest, so minus 0 squared. And all of that is plus the change in gravitational potential energy for both. So think about P. P moved 2 meters up the slope. So this is P. It moved 2 meters up the slope. Okay? 2 meters up the slope. And this theta, and we know what is sine theta. So sine theta is going to equal, let's call this H. H is what we are interested in gravitational potential energy. Sine theta is opposite over hypotenuse, which is 2. And I know that at the same time, sine theta is 0.4. So I know that the height, the vertical height that P moved is going to be 0.4 times 2, which is 0.8 meters. So this is the vertical height that I'm going to use in the MGH equation for P. So the change in gravitational potential energy for P is going to be the mass of P times G times H. H is positive 0.8 because P moved upwards relative to its starting position. Okay, now let's do the same for Q. So it's M 0.6 times G times H of Q. How much did H move? Did Q move vertically? So Q started like this. It moved down the slope 2 meters, and we know that this angle over here is 30 degrees. So sine 30 is equal to opposite, which is H, over hypotenuse, which is 2. So H is equal to 2 sine 30. So mg times h, it's 2 sine 30. However, this h is below my starting point, so I need to put it as a negative change in gravity. I'm not gaining gravitational potential energy, I'm losing gravitational potential energy. And when you solve this equation, you can get the value of V. So this left part is going to be negative 1.8 equals half times 0.3 is basically just 0.15. So this is 0.15 times V squared plus half times 0.6 is just 0.3 V squared. Plus I'm going to add this term, all of it together. So 0.3 times 10 times 0.8 plus 0.6 times 10 times negative 2 sine 30. This whole term is basically negative 3.6. I'm going to move this to the other side, becomes minus 1.8 plus 3.6 equals 0.15 plus 0.3. That is going to equal 0.45 V squared. So minus 1.8 plus 3.6 is 1.8 equals 0.45 V squared. Divide 0.45 both sides. V squared is equal to 1.8 over 0.45, and I'm going to square root both sides to get finally V as square root of 1.8 over 0.45. That's going to give me a final answer of 2.0 meters per second. Now, this is the easiest and most straightforward way to solve for the velocity using the energy method. You can try using the different two-particle system. So a whole system, you apply the work energy principle equation for P alone and then for Q alone, and then try to solve simultaneously, cancel tension, find the V, and you should end up with the same exact answer. Okay, now let's continue. This is the last question of the test. So this question goes like this. It says we have a particle x moves along a straight track starting from a point O at time t equals 0. The displacement of x from O at time t is given by this function over here. Find the time at which x is instantaneously at rest, and hence find the total distance traveled by x between this and that. This is a 6 marker. So let's see how can we solve that. So instantaneously at rest means what? Means that my velocity is equal to 0. The word instantaneously tells you that we want the instantaneous, the exact value at this instant, and this usually refers to differentiation. So if I differentiate ds by dt, that's going to give me the velocity. Differentiation of displacement is velocity. This is going to equal the differentiation of this function. So 3 over 2 times 3 is basically 9 over 2 t. 3 over 2 minus 1 is power of half, and this is just going to be minus 6. This is velocity. I want to equate it to 0 and solve. So I'm going to move the 6 because I'm trying to find when is the time where the velocity is 0, because instantaneously at rest. So I'm going to have 9 over 2 t power half equals 6. So t power half is going to equal 6. Divide 9 over 2. So 6 divide 9 over 2 is basically 4 over 3. So t is going to be, I'm going to square both sides. So t is equal to 4 over 3 squared, which is 16 over 9 seconds. Now, the second part of the question tells me find the total distance traveled between t equals 0 and t equals 16. Here you have to take care. If you know that, okay, I already have the displacement, okay, I already have the displacement, why don't I get the displacement at t equals 0 and t equals 16 and then subtract them? That's how I will get the total distance. No, this is how you will get the total displacement, because we have in between those two values, we have a moment where velocity was 0, right? So let's say the velocity was positive, it kept decreasing, and then it went, so this was the positive velocity. Here the velocity was 0, and then after the 0 velocity, you'll have a negative velocity, because we're slowing down until we shift direction, okay? So to find the total distance is different than when to find the total displacement. So what you can do is you can get the total displacement from 0 up to this time when we were moving with a positive velocity, or a negative, basically when we were moving at one direction, okay? Get the absolute value of that displacement, that's going to give you the distance, and then get the distance from 16 over 9 until 16, and then add both distances together. This is what we are going to do. So what we are going to do is at t equals 0, s was equal to 0. At t equals 16 over 9, s is equal to 3 times 16 over 9 to the power of 3 over 2 minus 6 times 16 over 9. That is going to give me an s value of 3 into 16 over 9 power 3 over 2 minus 6 into 16 over 9. That's going to give me a value of displacement of negative 3.56 meters. So I moved from the starting, if this is the origin, in this period of time from 0 to 16 over 9, I moved 3.56 meters to the right. 3.56 meters to the right, okay? Now I want to get what is the displacement from 16 over 9, okay, from this time, which is 16 over 9, because after this, I'm definitely sure that I switched direction, because at this point, after 16 over 9 seconds, my velocity was 0. So after that, I switched direction. So the displacement I'm going to get is fully in one direction. So it's not going to subtract. So at t equals 16, s is going to equal 3 times 16 power 3 over 2 minus 6 times 16, and that is going to give me an answer of 3 into 16 power 3 over 2. That's 6 times 16. That is going to give me an answer of okay. Part B says a second particle y moves along another straight track. It has nothing to do with the same track as x, starting from a point P at time t equals 0. So now our starting point for y is just point P. Yeah? The acceleration of y at time t is given as a equals negative 0.6 t plus 0.8. I like to write it this way. The velocity of y when it leaves P is this. When the velocity of y is negative 9.6, show that the displacement of x from O, so x is the previous particle, is equal to the displacement of y from P. So basically we need to know what time will y have a velocity of negative 9.6. When we get that time, we need to show that the displacement of particle y after that time is going to be the same as the displacement of x after that time, both from their original starting position. So let's start by first getting a velocity expression for y. So velocity is integration of acceleration by dt, so it's equal integration of negative 0.6 t plus 0.8 dt. So integrating that, that's going to equal negative 0.6 t squared over 2 plus 0.8 t plus the constant of integration. Now I know something, that the velocity of y when it leaves P is 7.5, and y leaves P at time t equals 0. So in other words, when time equals 0, the velocity was equal to 7.5. So I can use this information to find c. So velocity, which is equal to negative 0.6 divided 2 is negative 0.3 t squared plus 0.8 t plus c. So the velocity is going to be 7.5 when the t is 0. So if t is 0, that term is going to be 0, that term is going to be 0, and c is basically equal to 7.5. So what we can do is we can erase all of this and just write that the velocity is going to equal negative 0.3 t squared plus 0.8 t plus 7.5. This is the velocity expression for the particle y. Now, why did I do this? Because I want to find what time is going to, what is the time where the velocity is going to be negative 9.6. So negative 9.6 equals negative 0.3 t squared plus 0.8 t plus 7.5. So from here, I'm going to move actually everything to this left side because this looks like a quadratic, and I always like the leading term of x squared or t squared to be positive. So that's going to be 0.3 t squared minus 0.8 t. And then I'm going to have a minus 9.6 minus 7.5. So that is going to be minus 17.1 equals 0. So we can solve this quadratic using the quadratic formula. It goes like minus b, so minus negative 0.8 plus or minus square root of b squared, which is negative 0.8 squared, plus 2 into a, which is 0.3, into s, which is negative 17.1, all over 2 times 0.3. So from here, I'm going to get two values, which are, let me check, 0.8 squared plus 2 into 0.3 into negative 17.1 over 2 times 0.3. I don't know why I said that. It's not plus 2a. It's b squared minus 4 times a, which is 0.3, times c, which is negative 17.1. I don't know why I said that. The kinematics equations came into my mind for some reason. So let's try that again. Square root of negative 0.8 squared minus 4 into 0.3 into negative 17.1 over 2 times 0.3. First answer is going to be when t equals 9 seconds, and then the second answer I get it by changing this value from plus to minus. Is going to be a time where it's negative 6.3 seconds, and I can neglect this because time cannot be negative. So at time t equals 9 seconds, this is where the y has a velocity of negative 9.6. So I need to show that the displacement of x from O is equal to the displacement of y from P at this exact second. So to do that, it's very easy for me to get the displacement of x because I already have the expression, which is 3t to the power of So 3 into 9 to the power of 3 over 2 minus 60. So minus 6 times 9. When you put that in the calculator, that's going to give you basically 27. So that's going to equal 27 meters. That's the displacement. All we need to do is show somehow that the displacement of y is going to be the same. So over here, to get the displacement of y, I need to integrate velocity, because displacement is integration of velocity with respect to time. So that's going to be integration of this velocity expression. So integration of negative 0.3 t squared plus 0.8 t plus 7.5 with respect to dt. So that's going to equal negative 0.3 t cubed over 3 plus 0.8 t squared over 2 plus 7.5 t plus c. So again, in order to find c, I will need a condition, and I know that at time t equals 0, my y was at point P, so the displacement was literally 0. So at t equals 0, displacement equals 0. So displacement, which is 0, is going to equal this term, which is going to be 0 plus 0 plus 0, this term, this term, this term. So basically c plus c. So c is also 0 over here, and I will have my displacement as negative 0.3 divided by negative 0.1 t cubed plus 0.4 t squared plus 7.5 t. When I substitute 9 seconds now into here, so it's negative 0.1 times 9 power 3 plus 0.4 times 9 power 2 plus 7.5 times 9. If I put that in the calculator, that will give me, should give me 27, and that will make my answer. And indeed, it gave me 27 meters, which is the same as this one. So basically, this is how to go through this paper. This is a relatively tough paper. It's a medium paper. It has some interesting ideas. I really hope you enjoyed the video. Please don't forget to like and subscribe. Send me an email for the link of the course. Go check it. Thank you so much for watching, and have a nice day.